We want to find the points on the curve given by the parametric equations where the tangent lines are horizontal or vertical, and then check our work graphically. Well, we know the value of dy dx gives us a slope of the tangent line, and since we have parametric equations, dy dx is equal to dy dt divided by dx dt. Horizontal tangent lines occur where the derivative is equal to 0, which in parametric form would be when dy dt is equal to 0. So when dy dt equals 0 and dx dt does not equal 0, we'll have horizontal tangent lines. And then where dy dx is undefined, we would have vertical tangent lines. And notice the derivative would be undefined when the denominator, or dx dt, equals 0. So we can find the vertical tangent lines by determining where dx dt equals 0, again as long as dy dt does not also equal 0. So let's start by determining where we have horizontal tangent lines by determining where dy dt equals 0. Notice that y is equal to 2 sine 2t, and therefore dy dt will require the chain rule. This will be equal to 2 cosine 2t times 2, or 4 cosine 2t. We want to determine the values of t that make this derivative equal to 0. Well, notice if we divide both sides by 4, we can just determine where cosine 2t equals 0. Well, we know from the unit circle that the cosine function value is 0 at pi over 2 radians and 3 pi over 2 radians. But because we have a double angle here, cosine 2t will be equal to 0 when 2t equals pi over 2 and when the angle 2t is equal to 3 pi over 2. So if we solve this for t, we would multiply both sides by 1/2. So t is equal to pi over 4. And here we'd have t equals 3 pi over 4. But we're not done because this curve is going to be traced over the interval from 0 to 2 pi. So we want to find all the values of t from 0 to 2 pi where dy dt equals 0. But what we can do now is go back to where we had 2t equals pi over 2, and cosine 2t would be equal to 0 when 2t is equal to pi over 2 plus the period of cosine. Well, pi over 2 plus 2 pi would be equal to 5 pi over 2. Multiplying both sides by 1/2, we would have t equals 5 pi over 4. Next, 2t can also equal 3 pi over 2 plus 2 pi radians, which would be 7 pi over 2 radians. Multiplying by 1/2, we have t equals 7 pi over 4. Notice how this is still less than 2 pi radians. So all these values of t would make dy dt equal to 0, and therefore we should have horizontal tangent lines at the points with these given values of t. So let's go ahead and find the points at these values of t using our parametric equations. Let's start with t equals pi over 4, which means x is equal to 4 cosine pi over 4, and y is equal to 2 sine 2 times pi over 4 would be pi over 2. So here we'll have 4 times cosine pi over 4 is equal to square root 2 over 2. If we need to, we can verify it here on the unit circle. Remember, cosine theta is equal to the x-coordinate. So 4 times square root 2 over 2 would be 2 square root 2. And then y equals 2 sine pi over 2. Well, sine pi over 2 is equal to 1. So we have 2 times 1 equals 2. So one point where we have a horizontal tangent line would have an x-coordinate of 2 square root 2 and a y-coordinate of positive 2. Now let's consider t equals 3 pi over 4. Again, subbing into our parametric equations, we have x equals 4 cosine 3 pi over 4 and y equals 2 sine 3 pi over 4 times 2 would be 3 pi over 2. So cosine 3 pi over 4, going back to our unit circle, would be negative square root 2 over 2. So now we have 4 times negative square root 2 over 2, giving us negative 2 square root 2. And then sine 3 pi over 2 is equal to negative 1. So we have 2 times negative 1 equals negative 2. So the next point where we have a horizontal tangent line would have coordinates negative 2 square root 2 comma negative 2. Next we have t equals 5 pi over 4. So we have x equals 4 times cosine 5 pi over 4, and y equals 2 times sine 2 times pi over 4, or 5 pi over 2. Cosine 5 pi over 4, as we see here, is negative square root 2 over 2. So we have 4 times negative square root 2 over 2, which equals negative 2 square root 2. And then we have sine 5 pi over 2. 5 pi over 2 is coterminal to pi over 2. So notice the sine function value would be equal to 1. So we have 2 times 1, which is equal to 2. So the next point would be negative 2 square root 2 comma 2. We can probably figure out the next point just by looking at the pattern here, but let's go ahead and find it. If t equals 7 pi over 4, then x equals 4 times cosine 7 pi over 4, and y equals 2 times sine of 2 times 7 pi over 4, or 7 pi over 2. Well, cosine 7 pi over 4, going back to our unit circle, is equal to positive square root 2 over 2. So 4 times positive square root 2 over 2 is 2 square root 2. And then for 2 times sine 7 pi over 2, 7 pi over 2 is coterminal to 3 pi over 2, and therefore the sine function value would be negative 1. So we have 2 times negative 1 equals negative 2. So the last point where we have a horizontal tangent line would have an x-coordinate of positive 2 square root 2 and a y-coordinate of negative 2. Okay, now we still have to determine where we have vertical tangent lines, so now we'll determine where dx dt equals 0. Let's go ahead and do this on the next slide. This one will actually be much faster. Dx dt is going to be equal to negative 4 sine t. We want to determine where this is equal to 0. And if we divided both sides by negative 4, we really just want to determine where sine t equals 0. So again, quickly going back to the unit circle, since sine theta is equal to y, notice the y-coordinate is 0 at 0 radians as well as pi radians. So our solutions here are t equals 0 and t equals pi radians. So to find the points where we have vertical tangent lines, we'll substitute these values of t into the parametric equations. So when t equals 0, notice that x would be equal to 4 cosine 0, and y would be equal to 2 sine 0. Cosine 0 is equal to 1, so the x-coordinate would be 4. Sine 0 is equal to 0, so the y-coordinate would be 0. So the location, so one point where we have a vertical tangent line would have coordinates 4, 0. And then lastly, when t equals pi radians, we would have x equals 4 times cosine pi, and y equals 2 sine 2 times pi, or 2 pi. Well, cosine pi is equal to negative 1. 4 times negative 1 is negative 4. And sine 2 pi is 0, so the y-coordinate here is 0. So their location would be at the point negative 4, 0. So we found there are 2 points where we expect a vertical tangent line, and we have 4 points where we expect horizontal tangent lines. So let's go ahead and verify this graphically. Here's the graph of the plane curve using the parametric equations. Notice how there are 4 points where we'd have horizontal tangent lines. Notice there are four points where we'd have horizontal tangent lines here, 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 and here. And there are 2 points where we'd have vertical tangent lines here and here. So this graph does verify our work. Let's go ahead and label the coordinates. So this graph does verify our work, and just in case you're wondering, 2 square root 2 is approximately 2.83, or a little less than 3, as we see here on the graph from the points that we plotted. I hope you found this explanation helpful.